Look at your hand. It seems solid, ordinary, but inside every atom lies a secret, a vast reservoir of energy. This isn't science fiction, it's the reality of our universe. Hidden in the heart of matter is a power source waiting to be unlocked. Our journey takes us into the world of nuclear physics, to the very core of the atom. We must shrink down past everyday objects, past cells, to the building blocks of everything atoms. For centuries we thought atoms were indivisible, but we were wrong. The atom has a deep, energetic inner life. At its center is a place of incredible density and power, where the rules of our world bend. Understanding the atom's core means understanding the engine of stars and the energy that could power our future. The atomic nucleus is a realm 100,000 times smaller than the atom itself. Here, unimaginable forces bind the very essence of matter together. This is where the real cosmic drama unfolds. Let's begin our journey. Imagine an atom as a vast stadium with a marble at the center. That's the nucleus. Almost all the atom's mass is packed into this tiny space, making it incredibly dense. A teaspoon of nuclear material would weigh billions of tons. The nucleus is made of protons and neutrons. Protons are positively charged and should repel each other, yet the nucleus holds together. The secret? The strong nuclear force, the most powerful force in nature, but only over tiny distances. It acts like a super-strong short-range glue, binding protons and neutrons. Neutrons help stabilize the nucleus, acting as nuclear peacemakers. Inside the nucleus, there's a constant battle. Electromagnetic force tries to push protons apart, while the strong force holds them together. The balance between these forces determines if an atom is stable or unstable. Stable atoms last for billions of years. Unstable ones are destined to change, releasing some of their locked-up energy. This is the heart of atomic power. Not all nuclei are stable. Some have too many protons or neutrons, making them restless and unstable. To reach stability, these atoms transform. This is radioactivity. Unstable nuclei eject particles or energy to become more stable. They might release an alpha particle, a beta particle, or a burst of gamma rays. Each decay releases a tiny amount of energy. For any single atom, decay is unpredictable. But for many atoms, we see a pattern, the half-life. Half-life is the time it takes for half the unstable atoms in a sample to decay. Some elements have half-lives of billions of years, others just seconds. Radioactivity is everywhere, in bananas, granite, even in you. This natural background radiation is a constant part of life on Earth. It's a reminder that the universe is always changing, even at its core. The dance of decay shapes our world. Transformation is happening all around, and inside you. Can we harness the energy of the atom? Yes, through fission and fusion. Fission splits heavy nuclei like uranium-235 by adding a neutron, making them unstable and causing them to split. This releases energy and more neutrons, triggering a chain reaction. Uncontrolled, it's the principle behind atomic bombs. Controlled, it powers nuclear reactors, generating electricity. Fusion, on the other hand, is about slamming small nuclei together. In the Sun, hydrogen nuclei fuse to form helium, releasing even more energy than fission. Fusion is the power source of the stars and the ultimate energy source for Earth. Nuclear reactions release millions of times more energy than chemical ones. Chemical reactions rearrange electrons. Nuclear reactions rebuild the nucleus itself. The binding energy in the nucleus is immense. Tapping into it through fission or fusion unlocks massive power from tiny amounts of fuel. This is the true potential of nuclear energy. Nuclear physics isn't just about bombs. It's about power, healing, and discovery. Nuclear power plants generate electricity without greenhouse gases, helping fight climate change. In medicine, nuclear physics enables PET scans and radiation therapy, diagnosing and treating diseases with precision. Radioactive tracers reveal how organs function. Radiation destroys cancer cells. Nuclear technology powers space exploration too. Probes like Voyager and Curiosity use nuclear batteries, RTGs, to explore where sunlight can't reach. These batteries convert heat from radioactive decay into electricity, lasting for decades. The nucleus is a source of energy, healing, and exploration. Unlocking the atom's secrets has given us powerful tools. With wisdom, we can use them for good. Nuclear physics is the story of humanity's quest to understand and harness the forces that built the cosmos. The journey continues. The future is in our hands.